Okay, I had some technical difficulties there at the end of that section, so I had to create a part 2. So sorry, but here we go. Our example 2 is Al's produce stand, and I'm going to go ahead and read this problem to you here. Al's produce stand sells 7 ears of corn for $1.50. Barbara's produce stand sells 13 ears of corn for $2.75. Write 2 equations, one for each produce stand, that models the relationship between the number of ears of corn sold and the cost. Then use each equation to help complete the tables below. Okay, so I want you to go ahead and do that, and take all this space to go ahead and do that. This is going from this tabular, this table form here, and if you need to create your own table, go ahead and try that, give that a whirl. Don't take more than about 5 or 10 minutes to do that, and I will come back and go through it with you. Okay, so hopefully you guys chose to create a new table. I like this table I have going here a little bit better than theirs. And again, it's just the idea is to take some information and use it, apply it in your own way, okay, in a way that makes more sense to you. This type of table here makes a lot more sense to me. But the first thing I wanted to ask you is which would make more sense to use as a unit rate? Ears of corn per dollar, or dollars, cents per ear of corn. So think about your experience in life at the grocery store, at the farmer's market. Do we often talk in terms of ears of corn per dollar, or do we talk in terms of dollars per ear of corn? Okay, and think again in terms of what I had told you and what we had talked about concerning concerning a coordinate graph, and we have our x and our y. Our y, of course, is our dependent, and the tip I gave to you was that this dependent variable is most often the measure. It is a measure. Okay, so in this case, our measure truly is $1.50, and of course 7 is a measure in a sense. It's a number of units, but in terms of when I talk about dependent being a measure, it's more or less like a height, a weight, dollars, cents, cost, mass, etc., etc. Okay, so for me, it makes more sense that this y, which is always here in our chart, is the dependent. It's the measure. So in this case, it would be the cost, and our x, being our independent, would be here, and that would be ears. Okay, now the independent variable we often think about as the variable that can change. Okay, independent. Independent equals change. Okay, so when we go into a store, we can buy 5 ears of corn. We could change our mind and then buy 10 ears of corn. Okay, or change and buy 7. So this idea of independent being the change goes on the x-axis. So in this one here, ears would be best here, cost would be best as our y-axis. Okay, so we have some figures already. We are told from the table they gave us above. I'm just doing I'm talking about Al's now. Okay, we have 7 ears was $1.50. Okay, and now we have this over here is our K, or in this case we talk about something like food. We would look at it as our unit price. Okay, or unit cost. Okay, our K there. But they also give us some more figures. They want us to figure out the cost for 14, the cost for 21, and then they wanted you to figure out which number of ears of corn would actually cost you $50. Okay. Now looking at this one here, it's pretty clear. If you saw some relationships here, we're always looking at these proportional relationships. We can see that if we go from 7 to 14, we are just doubling the number of ears. If as we presume, our unit price stays the same. In this case, it does. This cost will double as well. Okay, so we would go up to $3 for 14. We could see the same thing happening here. We went up 7 ears of corn to get to 14. We go up another 7 to get to 21, and we would have another $1.50, and that would be $4.50. Okay, so we can fill those in pretty easily just using ratios, using equivalence, using this relationship without algebra necessarily. Okay, but our unit price is something we're going to need because we want to apply our y equals k times x formula. Okay, we'll want to be able to use that, so we need that k right here because in these two cases, in this case here, we have well, right here for when we try to figure out how many ears of corn are going to cost us $50. We only have at this point we only have the y. We only have this over here, $50. Okay. So to figure out unit, we know how to do unit price. This is not as neat as ones in the past have been. Okay. And to find that, of course, you're going to just divide your unit, your total cost by your units, which are 7. And if you did that correctly, and I don't care, use a calculator if you need to, work on your long division if you must as well. But if you did do that, you came up with 21 cents per ear. Okay, so this is our unit price, our constant of proportionality. Okay, unit cost. Let's call it unit cost. Unit price over per. Oh, sorry, no, I said we called it unit price, but that's per ear. Okay, per ear. All right, and this is going to remain the same here because it is our constant of proportionality. So it's always going to be 21 cents per ear, more or less. I mean, you had to round. I think it was 0.214. Okay, these are all going to be about the same. Okay. So what we do then is we have our unit price, we have our k. Okay, so in this case we have 0.21 times x. Okay, and that equals that. So 50 equals 0.21 or 21 cents multiplied by x. Okay, now as we know, what you do to one side, you do to the other. We're trying to simplify this. We're trying to isolate this x over here, and you remember in examples past, what we did is we just divided. Okay, and we divide that. Of course, we're going to divide that by 0.21, and we're going to isolate the x and have this be x. Now we have to divide this, of course, by 0.21 as well. That's $50. And if you did this again, using your calculator, working on that long division with decimals, always good practice to have to give yourself. You would have come up with a whopping 238 ears of corn cost you $50. Okay, applying the unit rate of 21 cents per ear. Okay, so we writing an equation for Al's, we figured that let's go back to Al again. Al's equation here for the proportional relationship was y equals 0.21x. Okay, so that's our equation there, and of course that's what we got right here over here. Okay, but now with Barbara, again, if you did all the math, checked your math twice, I'm sure you'd have come up with similar answers. If we first figure our unit price here by dividing 285 by 13, you came up with 0.22, so 22 cents per ear. Okay, very, very close to Al. Okay, 22 cents per ear. 14 would have cost you $3 and $3.08. And again, these are all kind of more or less is all rounding here. Okay, 21 would have cost you $4.62. I'm sorry, I'm at the wrong place here. Hold on. Excuse me. 21, $4.62. And again, just assuming the approximate per unit price of 22 cents. I mean, life is sloppy, okay? And it does get a little bit sloppy because you can see when you go from 285 to 308, you're looking at about 23 cents, but this is all the effect of rounding. And rounding is a reality, and estimating is a reality. Now, for $50, you would have been able to purchase 227 ears of corn, okay? And again, assuming our unit price was this rounded 22 cents per ear, okay? Question, what did you have to figure out? Write two equations. Who did that? We did the table. Where's the better buy? I guess Al is the better buy at 21 cents per ear. 22 cents per ear at Barbara. Not a real huge difference at all. But again, writing equations based on table information, determining, like we did here, which should be your dependent and which should be your independent variable, okay? And that may or may not be very obvious. In this case, it was, I thought, and again, I am usually of the mind that the measure goes on that dependent variable. Yeah, so therefore, I would suggest you do it that way. There may be some times or some points where that's not going to be as clear. Okay, and there are situations where in the real world we could use this y equals k times x relationship. For example, we talked about it before, this idea of distance equals rate multiplied by time. I had written this for you, I think it was in a couple of lessons past, that d equals rt. If the rate of a vehicle is going at an unchanging speed, again, the way that would be is if, for example, your mom or dad are on the highway and they put it into cruise control. If you've ever seen them do that, that keeps your vehicle going at a consistent speed. Very, very difficult to do otherwise. And when you're on a busy highway, of course, maintaining a consistent or a constant speed is more or less impossible. So, but if you are going at an unchanging speed, this constant, then the distance will depend on the time elapsed. Okay, so this d here is going to be dependent on the time you are driving if you have this constant rate. Okay, so in life, that is a way that this, and again we wrote it as y equals k, that constant times x. Okay, y equals kx. D equals RT is a very similar thing because the R is the rate, matches up with the K, our constant. Okay, so get rid of all that. Let's just go over our lesson summary. Lesson summary, I'd ask you this question: how do you find the constant of proportionality? You just divide to find the unit rate. So y divided by x equals k. Again, always looking at y as a function of x. Okay, so how do you write an equation for a proportional relationship? That would be y equals k times x, which we had just talked about, substituting the value of the constant of proportionality in the place of k. What is the structure of proportional relationship equations and how do we use them? X and y values are always left as, x and y values are always left as variables. And when one of them is known, they are substituted into the y equals kx formula to find the unknown using algebra. Okay, finding the unknown. This is what algebra is about. And hopefully you're getting closer and closer to thinking more algebraically, knowing how to build a table, that is going to make sense for you and is going to help you solve a problem. Okay? All right, so speaking of problems, here are problem sets below. Go ahead and finish your problem set, do your exit ticket, and I'll see you at lesson 10.